What's going on, my friend? It's Danny, and today I'm going to talk about how we can treat cancer naturally by being in ketosis. Now, before I get started, I want to say a couple of things. Number one, ketosis is not a cure for cancer, so I want to be very clear on that to begin with. And number two is, please don't take the content of this video as medical advice, because I'm not an expert. I'm just sharing with you the best that I've learned from the experts out there in my own way. Now, that being said, if you would like to do more research, I can recommend 3 people who are said to be the world's leading experts in this area. Now, the first one is Professor Thomas Seyfried. He is said to be the expert in this area. Number 2 is Dr. Dominic D'Agostino. He's done some great work in this field, and he's been made pretty famous or popular by Tim Ferriss. He's been on the Tim Ferriss podcast a few times, and he's actually featured in Tim's latest book, Tools of the Titans, as well. So that's the second person. The third person is Dr. Abdul Slocum, and he's done some great clinical trials in this area. So I recommend all 3 of them. I'll put their names in the description if you want to check them out. So let's move on. So how do we actually treat cancer naturally by being in ketosis? We can actually even prevent it as well, apparently. It's really interesting. So it's all about ketosis, so let's start there. So what is ketosis? Well, very broadly speaking, ketosis is a metabolic state where we burn fat as our primary fuel source rather than sugar. And that's what it boils down to. We're burning fat as our primary fuel source rather than sugar. So how does burning fat as our primary fuel source help us treat cancer? Well, to explain that, I first need to set some foundations, and I need to talk about how we actually create energy. So the energy that we all use for everything from blinking to thinking is something called ATP, or adenosine triphosphate. ATP is said to be the energy currency of the body. Now, how do we actually produce ATP? Well, we do it through a process called cellular respiration. And cellular respiration actually covers a number of metabolic pathways that run in the body. And many of these we actually use to extract fuel from food, and then we actually convert that into the energy, or the ATP. Now, it turns out there's 2 main fuel sources we use to do that. We can do it with others as well, but there's 2 main ones. And that's number 1, sugar or glucose, or number 2 is fat. So we either use sugar or glucose, or we use fat. So let's talk about sugar first of all. Now, in modern day society, it's fair to say that sugar is our number 1 fuel source, our number 1 nutrient, and that is because it is kind of rampant in our diets. It's in bread, it's in pasta, it's in rice, it's in all processed foods, it's in soda, we've got it in table sugar, it's everywhere basically. So sugar is our number 1 nutrient, and it turns out that we can actually store sugar or glucose in the bodies in a finite amount in the form of glycogen, that's in the liver or our muscle cells. And it takes about a day or 2 for us to burn off our existing glycogen, provided we're not taking in more glucose at the same time. And once that happens, the body undergoes a metabolic shift, and it goes from burning sugar as its primary fuel source to burning fat as its primary fuel source. And I've already mentioned that is when we are in ketosis. So fat was the second nutrient that we actually use to create this ATP, or the energy. So unlike sugar that we can store in only finite amounts, fat we can actually store in pretty much unlimited amounts, so there's an advantage there, is using fat as our primary fuel source. So when we actually burn fat, or we metabolize fat, we produce something called ketone bodies, and there's 3 ketone bodies that we produce. There's beta hydroxybutyrate, there's acetoacetate, and there's acetone, and we use these ketones to actually create the ATP, or the energy, and they're kind of, these ketone bodies are key to being in ketosis. Now, it turns out when we burn fat as our primary fuel source, it's actually more efficient than burning sugar, because we require less oxygen to actually produce a unit of energy, which is quite interesting. But not only that, when we burn fat as our primary fuel source, we actually produce less harmful byproducts. So unfortunately, when we eat food, a natural byproduct is something called reactive oxygen species, or free radicals. And they are harmful to us, but they're a natural byproduct. But when we burn fat as our primary fuel source, we produce less of them. So a great analogy I heard about burning fat compared to burning sugar is burning fat is like driving an electric car, whereas opposed to burning sugar is like driving a petrol car. So when you're burning fat, you're driving the electric car because it's more efficient and it's cleaner energy, so you're using less oxygen, but it's actually producing less pollution, so less reactive oxygen species. But when you drive the petrol car, it's like you're burning sugar, you're producing more pollution in the form of reactive oxygen species, but it's less efficient because you're using more oxygen to actually produce the energy. So anyway, so let's recap. So ATP is created through cellular respiration, and cellular respiration actually covers a number of metabolic pathways where we actually extract fuel from food, and those two main fuel sources are either sugar or fat. And sugar we can store in finite amounts, but fat we can actually store in pretty much unlimited amounts. Now, burning fat as our primary fuel source is actually a very natural state, but it's just not it's not very natural in modern world anymore, because the only time we actually really burn fat is after we've had a long sleep. We've burned off our sugar supplies, or many of them, and we start producing these ketone bodies in the blood, very low amounts, just mildly, and then we start eating again, and we start kind of filling up our liver with glucose again. So it's not very natural in modern day society, but it is a natural state. It would have been much more natural for our ancestors because they didn't have access to food every hour of every day like we do today. Now, they would have gone through periods of feasting or famine, so they would have gone extended periods of time where they didn't have access to any food at all. So they're used to being in this metabolic state of ketosis and burning fat as their primary fuel source, and they can go a long time, without actually eating because they've got unlimited reserves of fat pretty much. So those are the two fuel sources. Now, when we create ATP, we can actually do it in two ways. We can do it in the presence of oxygen, which is said to be aerobically, or we can do it without oxygen, which is said to be anaerobically. Now, when we do it aerobically with oxygen, we use something called mitochondria. Now, this is a really important part of the video. So mitochondria are the key to explaining how we treat cancer by being in ketosis. So what are mitochondria? Well, mitochondria are tiny little organelles that live inside all our cells. They form part of the structure of our cells. Number varies. Some cells will have 100, some cells have up to 100,000 mitochondria. And they are the body's main way of producing this energy, or producing this ATP. And as such, they're called the power stations of our cells. So mitochondria are really, really kind of key players when it comes to ATP production. Now, a quick kind of interesting example is the heart actually contains more mitochondria than any other organ in the body, and that because the heart works the hardest. It pumps for every second of every day, never takes a break, so it requires loads and loads of energy, so it's packed with mitochondria. So when we actually produce ATP, we can do it aerobically, and when we do it aerobically with oxygen, we use our mitochondria. Now, when we do it anaerobically, we don't use oxygen and we don't actually use our mitochondria. And doing it anaerobically is much less efficient in that we yield much less ATP as opposed to doing it aerobically. Now, here's the important part. It turns out that cancer cells, when they produce energy, they don't use oxygen, they don't use their mitochondria, and that's key. What they do is they ferment glucose. Now, cancer cells love glucose, it's their number one food, they love it, they love sugar. So I'll say that again. So cancer cells, when they're producing energy, they don't use oxygen, they don't use their mitochondria, they ferment glucose, and they actually love sugar, they love glucose. So how can we use that information to treat cancer? Well, when we're burning fat as our primary fuel source, which is being in ketosis, we're producing these ketone bodies and using these ketone bodies to create energy. And we do that in the presence of oxygen. We do it aerobically. So we are putting great stress on our mitochondria. We really need our mitochondria to do that. And our cancer cells really don't like that. Remember, cancer cells don't use their mitochondria. Now, it's not that cancer cells can't use their mitochondria, they can, but it turns out they don't have many mitochondria, and it also turns out that a lot of those mitochondria are damaged. No one really knows the reasons why they don't use the mitochondria, but they just don't. So when we're using fat as our primary fuel source, we're using our mitochondria, our cancer cells really don't like that. It puts them under tremendous strain. And what we're doing is we're starving them of their number one food. We're not giving them any of that glucose or sugar, which is exactly what we want. And that is really the crux of this video. It's how we can kind of treat cancer naturally by being in ketosis. So we want to eat fat as our primary fuel source, and we do that aerobically. We use our mitochondria massively when we do that, and the cancer cells don't like that. It puts them under strain, and we're cutting off their main fuel source, which is sugar or glucose, which is exactly what we want. Now, you might ask, if that's the case, then how come being in ketosis doesn't just starve all the cancer cells off and kind of kill them and cure cancer? It's a good question, because I asked it myself. Well, apparently, the thing about, the bad thing is that we never actually get rid of all our glucose in our blood completely. We've always got some glucose in the blood, and we can't eliminate it completely, so we'll always have like a base level. But what we can do is kind of lower that base level as much as possible, and we do that by being in ketosis and burning fat as our primary fuel source. So we want to get in ketosis if we want to treat cancer naturally. So how do we do that? Well, there's two main ways we can do it. We can either do it through fasting, which is very fast, or we can do it through a ketogenic diet. Now, not many people use the first way because of compliance issues. It's really hard to go for days without food, and a lot of people give up and fail. So even though it works really well, people just really struggle to do it, and it's understandable. The second way is easier, and that's through the ketogenic diet, and that's for an adapted diet. And a ketogenic diet, very broadly speaking, is where we get most of our macronutrients from fats. We want healthy fats, we don't want trans fats or anything like that. And we have very limited carbs, so probably about 30 grams of carbs a day at the most. And that doesn't count fiber, so we're talking about net carbs, which excludes fiber. And we have low to moderate protein. And it's different for all of us. All our bodies are different. We all have different gene variations called polymorphism, so we respond to foods differently, and our pathways are a little bit different. So you have to kind of work out your ideal diet yourself, or even better, get help from an expert and do it together. But the ketogenic diet is a main way to get into ketosis. The only thing, it takes quite a long time. It can take weeks or even months to get into ketosis for a ketogenic diet. Now, if you want to fast track it, you can do fasting. Basically, just don't go without food for a few days, and you'll burn off your existing sugar reserves, and your body will shift from burning sugar to burning fat as your primary fuel source, and then you can just maintain it with a ketogenic diet. So those are the two ways. Now, personally, I've been in ketosis a few times, and what I like to do is I like to combine the two. So what I do is I do an adaptive ketogenic diet where I have very low carbs, and I have probably moderate to high protein and probably moderate fat, but I have lots and lots of fiber. By having lots and lots of fiber, you actually kind of dampen any insulin spikes you might get from sugar or protein, and having insulin spikes can actually kick you out of ketosis, so you don't want that. So having fiber is a good kind of counteractive measure to make sure you don't get kicked out of ketosis. So I combine an adaptive ketogenic diet with intermittent fasting. So I don't go 2 or 3 days without eating. I'll eat within a limited number of hours in the day. So I'll eat within an 8-hour window in the day, and I'll go 16 hours with just water, and that will kind of help me kind of burn off my existing sugar reserves in my liver, etc. So that's the way I like to use. So that's ketosis, but how do you know if you're actually in ketosis? Well, thankfully that's quite easy. You can buy something called ketone strips. They're relatively inexpensive. You can get them in the chemist or buy them on Amazon, and basically you get a strip and you pee on the strip, and if it stays white and it doesn't change color, that means you are not in ketosis. Now, if it does change color, it means you are in ketosis, and you can see to the degree to how far you're in ketosis by a color code and chart. So what it actually does is it measures blood ketones, and the minimum amount of blood ketones you want to be is 0.5 millimolar, and that is basically when you're in ketosis, but that's pretty mild. Ideally, you probably want to be between 1 and 3 millimolar of blood ketones, and that's kind of the kind of nice sweet spot for being in ketosis. But again, it's different for everyone, so you kind of have to kind of work it out yourself or get help from a professional. But in terms of knowing when you're in ketosis, it's very easy. Just buy those strips, and that will tell you if you just pee on them. So that's basically it. So let me just recap to wrap up the video. So how do we treat cancer naturally? By being in ketosis. So remember, ketosis is a metabolic state where we burn fat as our primary fuel source rather than sugar. And when we're burning fat as our primary fuel source, we do it aerobically. We use our mitochondria, we put lots of stress on our mitochondria. Now remember, cancer cells don't use their mitochondria, they don't use oxygen, they like to ferment glucose, so they love glucose. So when we're burning fat as our primary fuel source, we're actually using our mitochondria, we're using oxygen, and our cancer cells don't like that. It puts them under stress, and we're kind of cutting them off of their favorite food, which is glucose. So remember, this is not a cure for cancer, because we always have some glucose in our blood anyway, so we can't get rid of it completely. It's not a cure, but it is now being used in conjunction with more traditional methods, and also some new methods as well. So hyperbaric oxygen therapy is being used as well. There's some fascinating research going on around a molecule called 3BP as well, which is very, very interesting. So it's being used alongside that too. So that's how we do it. Now, how do we get into ketosis? We can either do it through fasting, which is the quickest way, or we do it through a ketogenic diet, or the way that I like to use is a combination of intermittent fasting and an adaptive ketogenic diet. And how do we know if we're in ketosis? Well, we can use ketone strips, very inexpensive. You peel on the strip, and if it changes color, pretty much you're in ketosis, and you can see to which degree by looking at the charts that comes with the strips. So that is the video. I really hope you enjoyed it and got value from it. If you did, please hit the like button, and if you'd like to see more videos like this one, there's going to be more coming up, so hit the subscribe button. And until the next video, thank you so much for watching, and please take care.